Over the last few days, I've been working on sites like this one, where I go and have a look at a particular make of car, mark of car, and I look for pre-owned vehicles for sale, second-hand cars, and I analyse them. I build a database and I analyse them. And over the last week or so, I've analysed Aston Martin, Rolls-Royce, Lamborghini, McLaren, and a couple more. And today, I had a look at Lamborghini, and this is their website, and I did a search for just for any old pre-owned Lamborghini car, and it gave me this. And what it allows you to do, this is for North America, I should say, is to show all of the cars, the pre-owned vehicles that they have for sale in and around North America. And it's pretty big, it's a lot. It turns out to be around about 288 cars. Put them all into pounds sterling, because that's easier for me. And this is what you get. You get a picture of the car, the year of registration, the model, then the odometer reading, registration year confirmed, the interior style, the transmission, the price, and then how far this car is from where I am now, which is in Thailand. And they're all like that. So there you are. It looks nice and standard and straightforward. So I copy and pasted all of them, and to get this, and this is the list. Available Lamborghini pre-owned vehicles for sale from that website, 10th of March 2023, with me, Duncan Williamson. And this is what I found. If I start there and press Control and down arrow, and it goes down to row 6397. 288 cars with all this information in it. Well, that's fine. I've done this before. I've dealt with it before with different cars. And here's the information I mentioned. But there's a couple of issues with it. There's the name of the car and the year. There's the exterior colour. Then they repeat the odometer twice, and then there's the reading. Registration year twice, then there's the year. Interior twice, and then the scheme. Transmission twice, and then whether it's automatic, semi-automatic, or what is it, DCT, DTC, something like that. How far they are from me, and actually where they are. And then the price in pounds, a blank row, compare, shortlist, and view. However, if I can just highlight that all the way down to there, that's 19 rows. Now, in many situations, in fact, in every situation I've come across until now with this kind of research, this block of data is the same size as this block. But it isn't. 19, now it's 16. Now it's 22. There's a problem. Now, how do you get from this 6,400 rows of data, the blocks of information for each car may be different in height, number of rows, from every other car, any other car, all other cars, who knows? I did it, however. On the right-hand side here, you can see that I did do it. And this is a helicopter view of what I ended up with, which is an Excel table, pivot table, slicer, pivot chart, and then two scatter graphs. And I did all that based on that 6,400 rows of data for the 288 cars. Question is, how did I get for any number of rows from that column to the table you see on the right? In the next part of this video, how I did it. And this is how. The basic idea for a solution was to look for patterns. Since we have the first section 19 rows deep, then 16 rows deep, then 22. By the way, many of them were 23 rows deep. So I could have, say, sorted it and found all the 23 rows deep together, then dealt with the exceptions to that. But I didn't think that was a credible thing. So I looked for patterns apart from that. So the numbers of rows wasn't an option. And one thing I considered was this. I've got the year number there, and I thought, look, let me sort for left 4 in any row. But the difficulty there is that they've got the year there and again here. So I need to sorting out, if you like, because I see the rows are twice there. You might say, well, why not get rid of these duplications of names, row headers? That wouldn't help, would it? It just means everybody loses 2, 4, 6 rows, 8 rows in fact. That wouldn't work either. I then considered, is there a letter, a common letter, that we can see in each of these sections? Well, there is. Odometer, registration year, interior, yeah, lots of them. So I could find a way of focusing on one of those and say, all right, this is always in row 3, that's always in row 12, something like that. That would work. Also notice there's a blank row in everything. So I could search for blank. Sure, I could do that. I didn't try it, but I'm sure I could. And then we can work backwards from here to the end, not to the beginning, because we know that overall there's 19, 16, 22, 23 rows in this. So working backwards wouldn't work because we don't know how many are there. It could be 16, 13, you get the point. So that wouldn't help, wouldn't sort anything out at all. What I did in the end was this. I started doing this manually to try and get a flavour for what I was doing, what I was finding in terms of trying to get the pattern. And then I realised fairly quickly they all have the word view right at the end. It's the last word. It's the end word in every cars section. That's why the word view has a number against it. And what number is that? The row number. And I put a formula there. You can see the formula, the formula bar. Let me zoom in a bit. If left B25 first 4 characters equals view, then tell me the row number. Otherwise, tell me nothing. There you are. 25, row 25. 42, row 42. I'm then able to use that in this way. So look at column C and D now. For the first one, I've just hard-coded the number 6 because we know for a fact that the first car, this one, begins in row 6. Whatever else happens, it begins in row 6. And we've already just found out that it ends on row 25 with the word view. Never mind that. Because it's the first one, I'm able to simply transpose it. In other words, I chose this one manually, transposed it, and it filled across, as you can see, like that. No big secret for that one. Notice it's not the same width as the ones that follow. But then, this is how I use the numbers in column A. I'm able to say this. If error, sort A6 to A6397 plus 1. If there's an error, say nothing. So sort all of these numbers in ascending order and add 1. And here, this 25 is to sort, again, sort the same column, A6, A6397. So that's bound to be the smallest number. Then this one is simply all of these filtered down because they're all in the right place, aren't they? It doesn't matter where they are, whether it's 19, 16, 22, 23 rows, these numbers are in the right place. So we guaranteed that this one ends with 25, which we knew hard-coded anyway, but actually I put a formula in there. We know that this one ends in row 42. It does. We know that this one, the next one, ends in row 65. We've got that now, haven't we? And therefore, starting with this one, the smallest number plus 1, in other words, it's this one plus 1, because the second car begins in row 26. It's a bit of a circular reasoning, but it's exactly right. and then 43, it's the same formula which spills down A6, A16, A7 plus 1. So it's following down now this list essentially, and just add in 1, add in 1, add in 1, because in every case you simply add 1 to this one, end, beginning, carried down, brought down, carried down, brought down. There are no gaps between view and the next car, and that's it. It really is it. That's the solution to this problem. And then I transpose that way. Having done my manual work, where I simply transpose manually, I get to here, and a bit of clever footwork really. I do transpose, but then my formula to turn these into that. Left vertical, right horizontal is transpose, indirect, column B, and C11. In other words, make the formula to transpose equal to B109 to colon B131. That's how it works. That's the formula way of replicating what you see that I put manually here. So I did it manually to help me to set up and find a pattern. And then from then on, using transpose and indirect, fill down all the way to the end. That is how I turned that vertical, long vertical column into the much shorter but wider matrix. I then had a second issue that some lines, some rows are quite short, and the word view doesn't always end when the most of them end, which is in column AA, they end in X, U, X, so on. So just go down, you'll find that there is a sort of a pattern, but how did I solve that one? How did I get them all to end the way that you see now with that Excel table? Well, you don't see the word view anymore, I've just taken that out. They all end with a price. And how did I do that? I sorted the table. I sorted it. I turned it into text. In other words, I accept that the formula was right. Turned it into text. And again, studied the data, and I could see all of these would sort to give me, let me prove it, all the exact correct matrix, ending in column AA, starting in column E, I think it was. Yeah. So starting in E and ending in AA. So I sorted the table to force that to happen. And then at the bottom, right at the bottom, we could see whatever it was, 10, 12, 13 of them that end in column X. And whatever it was, 5, 6, 7, 10, 12 of them that end in column U. And I simply did some manual drag and drop because there weren't so many. That then is how I turned from start to finish that long vertical table into the fully complete Excel table you see there that allowed me now to start to analyze these data by means of that pivot table, which looks like that, as you can see on the right. And I use a slicer for the years. I put the years in the filter area. This is a pivot table in flux, by the way. I'm doing all sorts of things in there I could do. And this is a pivot table. Watch, sorry, a pivot chart. This is a pivot chart. As I change my selections in the slicer, then the pivot chart changes, as it should do. And then on the right-hand side, I've got a couple of scatter graphs, ordinary everyday scatter graphs, where I'm showing what I've called, let me zoom in so I can read it, odd MI all against price in GBP, they're all in GBP, remember. Odd MI, that's the odometer reading in miles, that's the number of miles that it's done. Okay, there we are. There's another feature in here, by the way, like the odometer, you might have spotted. Some of the values are in miles, and some of them are in kilometers. So I separated them out by means of this formula here, and this formula here. But there you are then, how to turn a long list with a variable number of rows in each section or element of the list into a standard Excel table that we can then use for further analysis. Interesting, I think. You might even want to work on an alternative view of this. Try and use the to rows function, use another function, and see how you do. And let me know in the comments. I'll be interested to find out. Okay, that's it with me, Duncan Williamson. Thank you for watching.